So, to create this project, I bought a spare controller. Now, the last video game kind of controller project I made with Arduino was use servo motors to physically press buttons and move toggle switches. Now, that is kind of slow and isn't much better than a human in any way. So the whole point of this one was to make it actually have a reason to be better than a human. So, this one I'm going to use either transistors or relays to electronically flip each of these switches, which means I'm going to take it apart and solder stuff all over this control board and then wire that up to Arduino and whatever I choose. So originally, I was going to use transistors to turn on and off the switches on the SNES controller. Now, I didn't do that just because I was unfamiliar with how they worked. I've searched up some things, but I really don't quite understand the circuits yet. I did get it working with a motor, but I couldn't get it working with the switches. So instead, I went to something that I do know a little better, which is relays. So here is a relay module, and it's basically a one-way electric switch. So here's a diagram of how a relay works. So basically it starts at the control circuit. As you can see, there's 2 pins coming out of it, but the module is going to have 3, 1 control pin. So there's going to be ground, power, and control. That's going to go to an electromagnet, a stationary one, that is going to attract a movable armature. When the movable armature moves to the electromagnet, the movable contact comes in contact with the stationary contact. Then, as you can see from the power supply and load that's connected to, that forms a complete circuit that is completely isolated from the original control circuit. So that's how it can be low power. Then, when the electromagnet is turned off, the spring, which was stretched when the movable armature came down, will pull it back and remove the contact. So as you can see, the relay modules came in and they're looking pretty good. So just like in the diagram, there's the DC in and DC out on the input side, and then IN, which is basically the control pin. So that's one that's going to go to the Arduino. Then on the other side, there's the NO, COM, and NC. The NO and NC are for whether you want it normally on or normally off for different projects. I'm going to have mine normally off because I want to be able to control when something happens. And then there's the common pin, which will lead regardless of NO or NC. So I'm going to wire that up.